Alright class, today we're going to deal with a problem that deals with specific heat. We will have to look up the specific heat of water, but I've done that for you. I'll give that to you guys in just a moment. But first, the idea of the problem is you have a chart here. It gives specific heats of certain substances, and we're trying to figure out what substance we have when we drop it into water. So we're given a 125 gram block of some mystery substance, and we need to figure out what it is. We heat your block to 90 degrees Celsius in an oven, and then lower into a cup of 0.326 kilograms of water. Water is initially at 20 degrees Celsius, and after we leave it for a while, we notice that the temperature raised to 22.4 degrees Celsius. We want to find the specific heat of the mystery block and what substance it is. So, to do this, first we have to know a couple things. First of all, specific heat of water, I'll go ahead and write down for you, is 4,186 joules per kilogram degrees Celsius. Okay. We also need the idea that if I have my thing of water, right, and I drop some kind of mystery material into it, the temperature, obviously, of the material originally was 90 degrees Celsius. Temperature of the water originally was 20 degrees Celsius, and we know that when you drop hot substance into a colder water, heat will flow from the hot substance to the cold. So given enough time, they will both have the same final temperature. So, and we know that after enough time was 22.4 degrees Celsius. So that was our final temperature for both. So first of all, we want to figure out, using our equation for specific heat, QV equals MC delta T. First figure out water. So we know that it was, the mass of water was 0.326 kilograms. The specific heat of water, which we just got from up there, was 4,186 joules per kilogram degrees Celsius. And then our change in temperature was final minus initial always, 22.4 is where it ended up, minus our initial of 20. And that gives us a heat exchange of 3,275 joules. So that's the amount of heat that the water gained, which means that's the same amount of heat that the substance had to give up to give that to the water. So we're going to use that number, 3,275, in just a moment. And we're going to solve for specific heat of the actual object. So again, let me put that again, 3,275. Again, same equation, Q equals MC, change in temperature. But this time we want to solve for C. So if we do a little bit of algebra, we get C, which is Q, the amount of heat, over mass times change in temperature. And if we plug that in, we will see the specific heat. Well, Q is the Q we had before, 3,275 joules, divided by the mass of the substance, which was 0.125. It's got to be in kilograms, times our change in temperature, which it ended at 22.4, and it started at 90 degrees. Now if you notice, it's going to come out as a negative number, but that's okay. It shouldn't come out as a negative number because this is negative because that's the amount it gave up. So negative, we're going to get a negative here, so it's going to cancel out. We're going to get a positive number. So it gives us a specific heat of 388 joules per kilogram degrees Celsius. So our units make sense, which if we compare that to our table, which I will bring back on here, about 388 is really close to copper, right? 387, 388. So it's most likely copper is our mystery material.